Okay, today on the bench for repair, we've got this 1960s space vehicle. It's a non-fall toy. They're writing this particular version, all being in Japanese, so I can't tell you what this particular toy was sold as. Here, if you can read all that, you'll know everything. At least you can see the correct battery placement. And I just have the body just sitting there. It's not put together because I thought you might want to see inside. So we're gonna, well, before I lift it off, let me say this same body, the same pressing was used on at least 6 different toys with different names. And they would, and some of them, instead of having like this blue cover here, it would be clear and it'd be a little cockpit and there'd be a little guy in there driving. Some of them, instead of this rotating antenna piece here, there'd be a piece of metal that came out in a flexible piece of wire, and on the end a little astronaut. So just like when this antenna is going to spin, the little astronaut would go flying around in circles. Basically the same toy. They could give it different names and dress it up a little differently. But I wanted to leave it basically apart so that we could talk about what's going on inside. Now, for those of you that aren't familiar with non-fall toys, the idea is that when they get to the edge of a table or something, they will automatically turn and move away, and then won't fall off over the edge. That's why they're called non-fall. I did make a video on how you could, zoom in on this. I'll put a link to this down below, but how you could 3D print your own non-fall vehicle and or robot, so you can make your own. There's a lot of things that are kind of important in one of these working, and balance is one of them, and we're going to talk about that more later. It takes 2 C-cell batteries to operate this particular toy, but modern C-cell batteries weigh almost twice as much as the carbon batteries back in the 1960s did, so it throws the balance off. Like I said, we'll come back to that. When I received the toy, it had multiple problems. One of the lamps was out, so I'd replace that to get both lights going. These lights move back and forth, and underneath these little bubble things, and it gives a nice light effect of the light moving back and forth. This blue thing is a clicker. You can see that there's a little piece of wire on there, and every time this crank right here comes around, it'll catch that and then make that nice clicking sound, which some of the boxes called a buzzing sound. Now you notice there are 3 drive wheels. They have this one which turns free, doesn't drive, this one which is geared to drive, and then this one which is geared to drive. And there's these 2 floating things in the front. Well, these 2 floating things, when they will keep the vehicle stable on a flat surface, but when it comes to a table edge or something, that will allow this to drop just enough for this wheel, which rotates in a particular direction, to then spin the whole vehicle away from the edge so it doesn't fall off. There are a couple of plastic gears in this thing. As you can see, there's one here that mainly drives the light movement, but there may not be enough light to see this. Let's see, let me turn the camera light on. Maybe we can get back up in there. That gear right there on the motor, that pinion gear, that's plastic as well, but that one's not split. That's still working and in good shape, as is this larger one here. But this antenna drive has got right there a plastic gear that drives it. Whenever this crank moves around, it turns this, which, well, maybe I can fake it this way so you can see what I'm talking about. You can see how that would move that. Anyway, that gear was in fact cracked, and I had to replace that. But even beyond that, because this antenna shaft, when you put the antenna on, you could push down on it. Someone, some kid, some person, who knows, had pushed down on this shaft hard enough that it actually bent the whole brass rod that's running through here, creased it down. So besides that gear being cracked and broken, the shaft was bent. So when I put the new gear on, I had to make sure I got the shaft straight again and get that on there. Get the light on there. As long as I had things apart, I put a drop of oil on the end of the motor, and there's a hole there where I could put some contact cleaner into the brushes to get it running. Now this toy will be a bit of a power hog because you've got two lights, and you figure each one of these lights is, I haven't measured it, just taking it roughly, they're flashlight bulbs in the 1960s, so they probably draw somewhere around 130 milliamps each, so you might have 230 milliamps, and you got a normal motor here, so you got another 150 milliamps. You're getting pretty close to drawing half an amp, so it's kind of a power hog. Now on the balance, I'm going to set it here, and you can see how it's sitting flat. The front is in fact down on the table. This wheel wouldn't quite touch. It's just above the table edge, so if either one of these were to drop off the edge of anything like that, now that wheel would contact, and that's what would cause it to spin and move away from it. But to keep it not just riding the ridge and to actually spin far enough to get away without falling off, they need to control the balance of the toy. They want it just enough nose heavy that that wheel can grab and move it, but not so heavy that it immediately goes back down again, because it won't work that way. Well, modern batteries like these one of these weighs more than two of the carbon batteries from the 60s. So when you put the batteries in the toy, if you use modern batteries, watch the front, see, it's not even on the ground anymore. It isn't going to work. Putting the body on, though, does shift the balance a little bit. So you can see it's getting close. And the body's not quite as far forward as it's going to be when we actually put it all the way together. It will, in fact, if it's put in the right place, just come down. But you could blow on it and make it raise up in the air, which means that there's no chance that that wheel is going to grab enough to spin the thing free from an accident. So instead of using modern batteries, you're going to have to play with these vintage toys. Pretty much go to like the dollar store and pick up their cheap batteries. These are their super heavy duty ones, and then right there they say for low drain only. So it's super heavy duty as long as your drain is low. So in other words, these even aren't ideal for this toy, because we just talked about how it's probably going to drop pretty close to 500 milliamps. But the weight will be right, that the toy will at least function for a short period of time using those batteries. I'm going to put these two in here, and when the toy is assembled, there's a back door that goes in here, and it basically just shorts these two together, because you have an on-off switch up here on the side, which I have already left in the on position, so all I need to do is short across these two batteries, and then you guys can get a rough idea of what's going on inside the toy when it's running. So you can see how those lights are moving, and the clicking sound, and the wheels. If I get my hand out of the way, how the wheels drive. That shaft is turning, as you can see, for the antenna. So the tricky part now is to get it back together. And why is it tricky? Well, it's tricky because you've got to line up all of these tabs pretty much at the same time, and that antenna shaft has got to be inside this little black coupler. I don't know if I'll be able to do this on camera, but I mainly wanted to show you the insides of the toy and explain how non-fall worked, just in case some of you didn't know or weren't even aware of this type of toy. So far so good. I got the front ones started, working on the side ones. I realize that most of this probably isn't on camera, but I don't have a camera operator, so we just have to make do the best we can. Okay, I think we've made progress. I think It's a little bit, hasn't popped in all the way, but the little tabs have in fact started. It's like putting the lid on a tuna can. I'm going to bend that front tab a little bit there to help hold that down and hold that down. What I'm fighting now is the tabs are in fact started in the slots, but the piece hasn't popped all the way down yet. It needs to, you almost need like a shoehorn. And get, there we go. See how we got that? I'm going to take one of these back ones and bend it a little. Kind of help hold things, hopefully, till I can get the other side to cooperate. It's getting there. There we go. All right. What have I got here? I know I'm off camera again. What I'm trying to do is bend a couple of these tabs to hold the thing together. I'm not going to bend them all until I've test run it, because you only get so many bends on the tabs before they break. So I want to make sure that when you've got it together, it in fact still works. And I think it will stay together long enough for us to test that. So on the back, here's your battery door. It has a little bit of a lock. Like I say, it just has to bridge across the two batteries. And there are pictures down inside there in case you get confused as to which way the batteries have to be oriented. If you get them in there backwards, you screw the toy up. You would bend that clicker and a few other problems. Wouldn't non-fall very well, probably. Okay, let's turn it on and see. All right. So we got lights, we got antenna, we got clicking. Let's see how our balance looks. You can see how it's just barely. That wheel hits, that's not going to drive it and keep it from falling off an edge, I don't think. No. So let's go ahead and give the dollar store batteries a try and see if things balance out a little bit better. This little workbench isn't the ideal place to be trying this. And the only other option would be to pack up the camera and move us into the kitchen area. But I don't think I'm going to do that. My purpose for this video wasn't really to demonstrate the non-fall action of this thing. It was to show you the insides and let you see how that type of a system works. And basically what I had to do to repair it. Man, these things don't weigh anything. It's the good old days. I'm going to give this a feel now. Oh yeah, see how much heavier that nose is? Alright, let's bend a few more of these tabs down so we know that they're not interfering with the function of the toy. Almost got them all down. I'll go back by and give them a complete press down when I'm all done, just to make sure they're like factory. Okay. Yeah, big difference. But whether it would turn, it would turn. Let's pull the camera back more. See that? It could have fallen off, but it didn't. So if you had a big enough room, it would be working. And look at that nice light show. So, trick is, if you find yourself with one of these 1960s non-fall toys, you need to remember that balance is very important. You're best going to the dollar store and buying some cheap batteries. That weigh so much less. Both those batteries weigh less than one of these. And you'll get your balance back where everything's working. Did we run with the antenna? I don't think we did. Let's run with the antenna. Oh yeah, that's much better effect. Good thing my hand was there, right? Well, we don't really have enough room on this little thing to demonstrate, but you certainly get the idea. So there you have it. There's your 1960s non-fall NASA, or United States or USA NASA space vehicle, made in Japan. And does it say anything else? Trademark TMs. Well, it was probably a Matsudaira toy. Modern Toys, yeah. ST. And again, if you want to do a screenshot and try to... here, let's turn this light off. We'll get less reflections. If you want to try to read any of that, you know how to decipher it, I'd say go for it.